There are humans walking among us with superpowers thanks to genetic mutations?
What? Get out of here.
It's true. Maybe you even heard about or seen someone who has. Super strength, feels no pain, or is extremely flexible. These people exist, and many of them have superpowers because of their favorable genetics. Here's a closer look at 5 superpowers caused by genetic mutations. First up is incredible strength. Wouldn't it be amazing to have natural superhuman strength? Imagine being as strong and looking as fit as the most awarded world strongman Mariusz Pudzianowski without the peds and with little training. Heck, I'd settle for just being able to carry all the groceries from the car in one trip without feeling like my arms will tear out of their sockets. Well, it turns out there are a few lucky people out there with genetic gifts giving them incredible strength. Some of these people have mutations in the myostatin gene, which encodes a protein that stops the growth of muscle cells. The mutations in myostatin enable muscles to grow larger and stronger. One person with this genetic gift is a German man who had both myostatin gene copies mutated, making him exceptionally strong and muscular, even at a young age. When he was 5 years old, he had bulging arms and leg muscles, twice the size of his peers, and could hold 2 7-pound dumbbells in horizontal suspension with his arms extended. Many studies have found that certain variations in the myostatin gene are more common in athletes compared to non-athletes, supporting that these genetic alterations enhance muscle size and performance. Another example is Eddie Hall, also known as the Beast. Apparently he has one faulty copy of the myostatin gene, which likely helped him become the world's strongest man in 2017. Also, many bodybuilders have been found to have variations in the myostatin gene, including Flex Wheeler. While most of us may not be gifted with such favorable genetics, scientists have been working on developing ways to block the myostatin protein, called myostatin inhibitors, to increase muscle size and function, with some success. One such promising inhibitor is YK11, which has been making its way through athletic circles. Other people, like the Liver King, have even tried gene editing to lower their myostatin levels. The next superpower we'll talk about is unbreakable bones. What if you could have extremely strong bones that don't easily break, sort of like the character David Dunn in the Unbreakable movies? You'd be able to walk away from car accidents without major injury, or jump from tall buildings, or be that rare person not lying about their elevated scale weight being caused by their high bone density. There are indeed humans among us that have this special trait thanks to mutations in the SOST gene. The gene encodes the protein sclerostin, produced mainly by cells called osteocytes, which block formation of bones. Individuals with one defective copy of the SOST gene have increased bone mineral density, meaning stronger bones. Fortunately, scientists have successfully created antibodies to block the action of sclerostin. One of these antibodies, romosozumab, was recently approved by the Food and Drug Administration as a promising new treatment for postmenopausal osteoporosis. Hey, if you're enjoying this video, consider supporting our channel by liking this video and subscribing. The next superpower we'll talk about is having no or little pain. Wouldn't life be much easier if you could feel no pain? You could fight bad guys without worrying about getting hurt, or finally have the courage to get your face pierced. Turns out there are mutations in many genes that can decrease or eliminate the sensation of pain. One such gene is FAAH, which encodes the fatty acid amide hydrolase enzyme. Mutations affecting this gene can cause insensitivity to pain, decreased anxiety, and even improve wound healing. These mutations cause elevated circulating fatty acid amides and enhanced endocannabinoid signaling, which is important for pain perception. About 3 years ago, Jo Cameron made headlines when researchers found 2 mutations affecting her FAAH gene. She gave childbirth and had broken limbs, severe hip and thumb osteoarthritis, and surgeries with little or no pain. Thanks to individuals like Jo, scientists have a better understanding of the FAAH gene and EC system. They've been using this knowledge to create pain medications, such as the FAAH inhibitor URB597. The second last superpower we'll look at is needing less sleep. We all know or heard that sleep is critical to good health. Consistently getting less than 8 to 9 hours of sleep per night increases your risk of cardiovascular disease, cancer, dementia, metabolic issues, and a weakened immune system. But what if you could be like Batman? Get little sleep without it affecting your health or ability to function. What would you do with all that extra time? Maybe start a side hustle to become a billionaire, create some cool gadgets, take up martial arts, and start dating? Well, as you probably guessed, turns out a few among us have just that type of luck because of genetic variants in certain genes. One such gene is DC2, which encodes a repressor of a peptide that controls arousal and wakefulness, also known as orexin. Researchers found that individuals with mutations in DC2 only need roughly 6.25 hours of sleep per night. A more recently discovered gene is ADRB1, which encodes the beta-1 adrenergic receptor in the brain that binds the hormone adrenaline and the neurotransmitter noradrenaline. Researchers identified a 3-generation family of short sleepers that had a mutation in the ADRB1 gene. The individuals in this family have better quality and efficiency of sleep with only roughly 6 hours of sleep per night. Also surprising was that they were more energetic and optimistic, better multitaskers, and had a higher pain threshold. Thanks to these discoveries, scientists have been working on developing new medications to help people fall asleep and improve sleep quality, such as suvorexant. The last superpower we'll talk about in this video is having super flexibility. How great would it be to be extremely flexible and not just to impress that girl in yoga class? Genetic variations that make people extraordinarily flexible can occur in genes encoding different subtypes of collagen, which is a major structural component in the body. Mutations in these collagen genes result in overly flexible joints because the connective tissue that holds the joints together is looser and stretchy. These individuals actually have a condition called hypermobile type Ehlers-Danlos syndrome. One famous individual with this syndrome is Daniel Brown Smith, a 7-time Guinness World Record holding contortionist. Another condition that results in joint hypermobility in some individuals is Marfan syndrome. Marfan syndrome is caused by mutations in the FBN1 gene, which encodes a protein necessary for the proper formation of elastic fibers in connective tissues. Not only do some individuals with Marfan syndrome have joint hypermobility, but most are also tall and have a longer wingspan to height ratio. The 23-time Olympic gold medalist swimmer Michael Phelps has been suspected to have Marfan syndrome because he fits some of this criteria. He has joint hypermobility, is tall, and has a long wingspan. So how can this help the rest of us Joe Blows? Well, in more ways than we can imagine. Understanding the structure and function of the proteins, such as collagens and fibrillins, helps researchers develop treatments for various diseases and improve organ health. Equally important, scientists are finding that modifications to these proteins in their local environment, called the extracellular matrix, is a key driver of aging. A better understanding of how the ECM is modified in aging may one day help us slow or ideally reverse the aging process. So, would any of these superpowers make your wish list? It should be noted that while having these types of powers may sound amazing, some of these conditions come with burdens. For instance, individuals with Marfan syndrome are at a higher risk of tearing their aorta, which can be life-threatening. Also, having no pain can be a burden as well. Nature created the sensation of pain for a reason, to protect us. Not being able to feel pain can result in serious injury or even death. Case in point is Jo Cameron. She usually notices that she's burning her hand from the smell of burning flesh. So these are only a few of the superpowers that have been traced back to having genetic origins. We'll release a video next week with 5 different superpowers that are caused by genetic mutation. Be sure to subscribe to our channel for more content on genetics, health, and longevity if you like this video.